Hi guys, welcome back to my class. So before we start, please don't forget to hit the subscribe button and the notification bell for more video lessons. So for today, we're going to talk about the introduction about sequences and series. So in this specific lesson, you're going to have a background about the different types of sequences and also on how to generate patterns and how to solve the sum. Okay? Now, let's talk about sequences. So the question is, what are sequences? So when we say sequences, can you think of an example of sequence related in English, science, history, and MAPE? So let's start first with English. So with English, this is very familiar to you. We can actually relate sequences wherein the topic is sequencing events. So when we say sequencing events, you're going to number the sentences in order, like for example, how to cook adobo and everything, or instructional or informative. Okay, so that's what how we can relate sequence or sequences in English. So I think that that is very familiar to you, because since when you were in elementary up until now, you are sequencing events in English. And then how about in science? So what are the topics that we can actually integrate or relate with sequences? First is life cycle of animals. Okay, so of course, when you say life cycle, they will start from egg, and then until such time that they will be hatched, and then they become the species that we know. Like for example, frogs, mosquitoes, and even for human. So before a baby comes out, okay, so it should be inside the womb from the first month until the ninth month of development before it is ready to be born. Okay, how about in history? So in history itself is a sequence because we are talking about past events. Like for example, the order of the presidents in the Philippines, the order of presidents in the United States of America. So that is an example of sequence in history. Okay? And many more. And then, how about in MAPE, music, arts, PE, and health? So how can we relate sequence? Example, in music, we can actually relate it in dancing, okay? And then in music as well, songs, okay, how to compose, and so on and so forth. And then for PE, of course, okay, how do you do the routine and so on and so forth. That is actually an example of sequence. And then sequences in everyday life. Our everyday routine is an example of sequence. So when you wake up, and then after we wake up, you will eat, you will do the things or chores that you need to do, and then after that you will eat your lunch, you will eat your dinner, and then it's a cycle. You will wake up again and do the same things. Okay, so it depends on what you are doing in your life. And of course, when we are talking about success, remember that there is no shortcut to success. So before you become successful, of course, you have to earn your degree by starting first with the elementary, high school, and then until you reach college. So it means it is a step-by-step process. There's no shortcut to success that for a period of 12 months you are able to earn your degree. No. Okay? So after you have earned your degree, of course, you have to work hard so that you will become more successful. Okay? That's it. And then let's talk about sequence. Sequence may be generated from patterns, shapes, or rules. What do we mean by that? So when we say sequence, let's say for example 2, 4, 6, 8. What is the pattern or the rule? Without the pattern, shape, or rule, you cannot actually say that it is a sequence. When we say sequence, it must follow a certain pattern, rule, or shape. And then, mostly we're going to talk about number sequence. What is a number sequence? List of numbers following a certain pattern. Okay, let's say for example 5, 10, 15, 20. So what is the pattern? That's skip counting by 5. Okay, so that's the pattern. Without a pattern, we cannot say that that is an example of number sequence. Or simply, if we're going to have 1, 2, 3, 4, 5. So what's the pattern of that? Adding 1. Okay, so without that pattern, we cannot say that that's an example of sequence. Okay, you have to take note that without rule or without pattern, you cannot actually say that a specific sequence is really a sequence. How about term? Each number found in a sequence, let's say we have the sequence 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 are the terms or elements of the sequence. As simple as that. Okay? Now, when we say terms as well, that is the makeup of the sequence. We have two types of sequence. So the first type is finite sequence. Okay? So when we say finite sequence, is a sequence with a definite number of terms. So it means the terms or the elements are countable. Countable. You can count them by just simply looking at them. Okay? So that's what we mean by finite sequence. So example, letter A, we have 2, 4, 6, 8, 10. Okay? How many terms are there? There are 5. So if that's the case, we can say that this is an example of finite sequence because you can actually see the actual number of terms. Okay? So 2, 4, 6, 8, 10. And also, for letter B, we have 1, 2, 3, 4, 5. So if it is a finite sequence, there are two parts that we need to take note. We have the means and the extremes. When we say means, these are the terms within the extremes. Within the extremes. And then extremes, or of course, are the outer terms. Okay, outer terms. In this case, we have 1 and 5 as the extremes. And also, for example, 8, 4, 6, and 8 are what we call means. And then 2 and 10 are what we call extremes. Okay, that's it. Next, we have the next type of sequence, which is what we call infinite sequence. So infinite sequence is a sequence with no definite number of terms. So it's the opposite of finite because in infinite, you cannot count the terms. So it denotes infinity. Infinity, no ending. Okay, there are so many terms wherein you cannot count them, unlike the finite sequence. And then, of course, we are using ellipsis symbol to indicate that other terms follow but are omitted for convenience of writing. For convenience of writing. Of course, if the terms are infinite, you're not going to write them all. Okay, um, you will not finish writing. And then example, we have 2, 4, 6, 8, 10. We don't have only 5 terms here. As you can see, this is an example of infinite sequence because at the end of the last term, we used ellipsis symbol. Ellipsis symbol. So if there is an ellipsis symbol at the end of the last term of a sequence, that is an example of infinite sequence. Okay? Next, those are the two types of sequence. Now let's have the different types of sequences. So this is just a background. In the coming weeks, we're going to talk about them one by one. Okay? One by one. The first type of sequence is what we call arithmetic sequence. Arithmetic sequence. What is an arithmetic sequence? Let's find out using these examples. So find the next term of the sequence 1, 3, 5, 7 and 2, 5, 8, 11, and 14, and lastly 46, 41, 36, 31. So let's have the first example. What do you think is the last term? Oh, I'm hearing 9. So therefore, the last term here is 9. How did we say that the last term of this sequence is 9? Okay? Of course, in arithmetic sequence, we have what we call the common difference, wherein you have to get the common difference so that you can add it to the last term to get the next term. Okay? So, example, how are we going to get the common difference? You can get the common difference by subtracting. So 7 minus 5. Okay, so this is the order of when you subtract. You have to subtract from right going to the left. From right going to the left. So example, 7 minus 5 is 2. 5 minus 3 is 2. 3 minus 1 is 2. So therefore, our common difference is 2. In arithmetic sequence, we have the common difference wherein we are going to use this common difference to get the next terms of the sequence. So 7 plus 2 is 9. Remember that to get the next term, In an arithmetic sequence, you have to add the common difference with the given last term. Okay? Oh, let's have the second one. 2, 5, 8, 11, 14. What do you think is the last term? The last term is 17. So how did we say that the last term is 17? Of course, you have to get first the common difference. What is it? 14 minus 11 is 3. 11 minus 8 is 3. 8 minus 5 is 3. And 5 minus 2 is 3. So to get the next term, you have to add. So 14 plus 3 is 17. So the common difference here is 3. So how are we going to get the common difference? You are going to subtract from right going to the left. And then next, we have 46, 41, 36, 31. So what do you think is the last term? Okay, so the last term is what? 26. So how did we say that it is 26? What's the common difference? Of course, we need to subtract. So 31 minus 36, it's negative 5. 36 minus 41, it's negative 5. 41 minus 46, it's negative 5. Teacher, is it possible to have a negative common difference? Yes. Okay? So the common difference here is negative 5. And then to get the next term, you have to add negative 5. So 31 plus negative 5 or 31 minus 5 is 26. Take note of that. Take note of that. Next, we have the geometric sequence. Find the next term of the sequence 1248, 2048, 1024, 512, 256. Okay, so let's start first with this one. What is the rule for geometric sequence? 1248. What do you think is the next term of the sequence? I'm hearing 16. So let's check if it's really 16. So how are you going to check? If in arithmetic sequence we're talking about common difference, here we are talking about common ratio. Why common ratio? To get the common ratio, you have to divide instead of subtracting. 8 divided by 4 is negative 2. No. Positive 2, sorry. 4 divided by 2 is 2. And then 2 divided by 1 is 2. So if we actually divided to get the common ratio, which is 2, so we have to multiply to get the next term. So 8 times 2 is 16. If in arithmetic sequence, we are subtracting and getting the common difference and adding to get the next term. In geometric sequence, we are using division and multiplication. Division in getting the common ratio and multiplication in getting the next term of the sequence. Let's have the second example. 2048, 1024, 512, 256. First thing is we have to solve for the common ratio. So 256 divided by 512, it is 1/2 or 0.5. 512 divided by 1024, it's 1/2 or 0.5. And lastly, 1024 divided by 2048, it's also 1/2 or 0.5. Therefore, to get the next term, just simply multiply 1/2 or 0.5. So the answer here is 256 times 0.5, it's 128, wherein the common ratio that we used is 0.5 or 1/2. That is geometric sequence. Harmonic sequence. Take note of this, class. So when we say harmonic sequence, okay, we are dealing with fractional terms wherein this is related to arithmetic sequence. Example 4. Find the next term of the sequence 1/3, 1/7, 1/11, 1/15. Just look at the denominator and get the pattern using the rule for arithmetic sequence. So what do you think is the next term? Okay, subtract from right to left. 15 minus 11. Okay, so the common is 4. The common is 4. The common difference is 4. To get the next term, add 4 to the denominator. So the answer is 1/19. So that is the next term of the sequence. Again, it is related to arithmetic sequence. You have to follow the rules of arithmetic sequence in terms of the denominator. Okay? So we have 5 halves, 5 thirds, 5/4. So how are we going to actually find the next term? Just look at the denominator. Remember that 5 has a denominator of 1. We have 2, we have 3, we have 4. Therefore, the last term is 5/5 or simply 1. That is harmonic sequence. Next, we have Fibonacci sequence. Again, we have Fibonacci sequence. Find the next term of the sequence 1, 1, 2, 3, 5, 8. How are we going to solve the next term? Remember this. This is the rule. Okay? This is the rule. You have to add the previous two terms, 1 plus 1, to get the next term. So, 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. And then 3 plus 5 equals 8. So, to get the next term, you have to add 5 plus 8 equals 13. So, that is the missing term. Okay? That's how you're going to solve for a Fibonacci sequence. This was developed by Leonardo Fibonacci. This has a lot of applications that you will know in the coming weeks. Alright, so those are the different types of sequences that we're going to talk about. So let's have the terms of a sequence. So in this case, we are going to learn on how to actually solve for the terms of a sequence given the general term or the formula. We can call it also as formula. So example 5, finding the terms of a sequence instruction, list all the terms of each finite sequence. So for letter A, we have a sub n equals 3n squared minus 1 for n is at least 1 and n is at least 5. So therefore, we are looking for the first term up to the fifth term. That is the range. Okay? That is the range. So therefore, we are going to change the n with the position of the term. Let's say, for example, we are looking for the first term, a sub 1. Change all n to 1. So therefore, we can have 3 times 1 squared minus 1. Then simplify this one. You can actually use your calculator to input all, and then you can actually have the final answer. So 1 times 1 is, or 1 squared is 1 times 3. 3 minus 1, it's 2. So a sub 1 is 2. How about a sub 2? And now change all n to 2. So 3 times 2 squared minus 1. Simplify. 2 times 2, 4 times 3. Okay, it's 12 minus 1, it is 11. That is the second term. So how about the third term? A sub 3. Change all n to 3. So 3 times 3 square minus 1. So 3 times 3 is 9 times 3, 27 minus 1 is 26. That is the third term. Let's have the fourth term. Change all n to 4. 3 times 4 square minus 1. Okay, and the next thing is 4 times 4 is 16. Times 3, it's 40. What is it? 48. Minus 1, it is 47. Next, last, a sub 5. 3 times 5 square minus 1. Then 5 times 5 is 25. Times 3, 75. Minus 1. So therefore, a sub 5 is 74. These are now the 5 terms that we are looking for. For the final thing, you have to actually write all the terms. Therefore, 3 dots means therefore, the terms are 2, 11, 26, 47, and 74. So this will serve as your final answer. Okay? So whenever when we say listing down the terms, okay, you have to follow the formula to solve them. Okay? It depends on how many terms are there in the specific range. In this case, we have 5 terms from first up to the fifth. Next, we have a sub n equals 1 over n plus 1 for n is at least 1 at most 4. So it means we are looking for the first term up to the fourth term. So to get that, just change n with the position of the term. A sub 1 equals 1 over 1 plus 1. Okay, while a sub 2, okay, is 1 over 2 plus 1. While a sub 3 is equal to 1 over 3 plus 1. And then a sub 4 is 1 over 4 plus 1. And then simplify. 1 over 1 plus 1 is 1 half. Okay, 1 over 2 plus 1 is 1 third. 1 over 3 plus 1 is 1 fourth. And lastly, 1 over 4 plus 1 is 1 fifth. Okay, to write the final answer, therefore, the terms are 1 half, 1 third, 1 fourth, and 1 fifth. This will serve as your final answer. Okay? Next. So that's what we mean by that when we say listing all the terms. What if we are only looking for the specific term? That's what we call nth term of a sequence. Okay, example number 6. Find the 7th and the 10th term of the sequence which nth term is given by. So the formula is given and then we are looking for the 7th and the 10th term. So how are we going to do that? Just simply substitute n to 7 and 10. So first is a sub 7, that's the one that we are looking for, equals 1 over 7 plus 1 times 7 plus 2. Then for a sub 10, we have 1 over 10 plus 1 times 10 plus 2. Then let us simplify. 1 over 7 plus 1 is 8 times 7 plus 2 is 9. Then simplify. What is 8 times 9? Can I hear an answer from you? 8 times 9 is 72. So therefore, the answer is 1 over 72. This is now your 7th term. How about the 10th term? Okay, simplify. 10 plus 1 is 11 times 10 plus 2 is 12. Okay, then 11 times 12 is 132. Therefore, the final answer is 1 over 132. So in this specific example, we just solve the specific terms that are being asked. Unlike in the previous example, we need to solve all the terms. We need to solve all the terms. Okay? So to better understand this one, let's have the next example of this. So find the 7th term and the 10th term of the sequence which the nth term is given by a sub n equals n times n plus 1 over 2. Okay, so this is how we are going to do it. We will be solving for a sub 7 and a sub 10. Okay, then, substitute the value 7 times 7 plus 1 over 2. And in this case, we have 10 times 10 plus 1 over 2. Then simplify. 7 times 7 plus 1 is 8 over 2. In this case, 10 times 10 plus 1 is 11 over 2. Then the next thing, simplify. Okay, so 7 times 8 is 56 over 2. And 56 over 2 or divided by 2 is 28. So that is a sub 7. How about a sub 10? 10 times 11 is 110. Divided by 2. So the final answer is 55. Our a sub 7 now is 28 and our a sub 10 is 55. Okay? So what if the terms are given, unlike this, the terms are given but the formula or the general term or the nth term is not there? Okay, how are we going to do that? We call it now general term or the nth term of a linear sequence. So we are going to talk about only linear sequence, not the quadratic one. So we will follow the general equation a sub n equals a n plus b. This is for linear sequence. Again, this is for linear sequence. Okay? Example, finding the general term of a linear sequence. So this is what I'm talking about. The terms are given, but the general term or the formula is not there. All we need to do here is to solve for the general term or the formula of this sequence. Okay, the initial step is get the constant and check whether it is a linear sequence or not. How are we going to do that? Just subtract or get the common difference in the first level. Okay, so subtract from right going to the left. So 33 minus 26 is 7. 26 minus 19 is 7. 19 minus 12 is 7. And then 12 minus 5 is 7. 12 minus 7. So therefore, we can verify now that this is an example of linear sequence because in the first difference test, all the differences are equal. Therefore, this one is a linear sequence and 7 is what we call a constant. Then the next thing that we have to do is to actually create equations 1 and 2 to solve for the values of a and b. So using the general equation of linear sequence, a sub n equals a n plus b. Let's create the first equation using the first term. When we say first term, this is the n is 1. Okay? N is 1 and then a sub n is equal to 5 or the value of the term itself. Then substitute a sub n is 5 equals a and the n is 1 plus b. Then arrange it. A times 1 is simply a plus b equals 5. This will serve as your equation number 1. Now let us create the equation number 2 using this one or the second term wherein n here is equal to 2. So n is equal to 2 and a sub n is equal to 12. Okay? Then substitute the values of the general equation. So 12 is equal to a times 2 plus b. Guys, in creating the equation 1 and equation 2, please make sure to just use the first term and the second term. Okay? For it to become easier. Okay? So a times 2 is 2a plus b equals 12. So this will serve as your equation number 2. Teacher, what's the next thing that we're going to do? We are going to solve for a and b. So first is let's solve for a by subtracting equation 2 minus equation 1. Okay, so your equation 2 is 2a plus b and then please arrange it in column form. So 12 equals 12 minus a plus b equals 5. Then subtract. So 2a minus a is a. B minus b is 0 equals 12 minus 5 is 7. So therefore the value of a is 7. So we need to solve also b. How? Solve b using equation 1. So this is our first equation. A plus b equals 5 wherein the value of a is 7. Substitute 7 plus b equals 5. Therefore, b equals 5. Using addition property of equality, we have to remove 7 here by getting its opposite. Opposite of 7 is negative 7. So therefore, b is equal to 5 minus 7 or negative 2. Now, teacher, what are we going to do now? You will now create the general term or the formula using the values of a and b. A sub n equals a n plus b, wherein the value of a that we are able to solve is 7 and the value of b is negative 2. Substitute a sub n equals a times, we have to change a to 7. Let's erase this first. Okay, so value of a is 7 n plus negative 2 or simply a sub n equals 7n minus 2. So this will serve now as your final answer. Teacher, how are we going to check it? So this is how you will check it. You can use all the terms in checking, but let us try only the first term, okay, to verify if our general equation is correct. But class, you can still use the other terms. This is not actually requiring your solution, but the thing is for you to be able to verify and be complacent of your equation or general term, you have to check. So our a sub 1 is 5 and this is now the checking part. Okay, so a sub 1 is 5 and n is equal to 1. Using now the general equation a sub n equals 7n minus 1, let's check. So a sub n now will be 5 equals 7 times 1 minus 2. Remember that they should be equal or both sides must be equal. So 7 times 1 is 7 minus 2. So therefore 5 is equal to 5. You can still check using the other terms of the sequence. Okay, that's it. In our next example, for us to be able to omit this specific step, you have to remember that if you are going to use the first term, a plus b is always constant. If you are going to use the second term, 2a plus b is always constant. What are you going to change is the first term here is 5 and here is 12. To better understand this one, let's have the next example. Find the general term of the sequence 7, 11, 15, 19, 23. Okay, so this is how you are going to do it. Subtract again to verify if it is a linear sequence of or not. So 23 minus 19 is 4. 19 minus 15 is 4. 15 minus 11 is 4 as well. And then 11 minus 7 is 4 also. So therefore, we can say that 4 is a constant. Then the next thing that we have to do here, guys, is we have to create the equations. Okay, so we are able to verify that it is a linear sequence because in the first difference test, the differences are equal. Okay, so for the first equation, okay, that's just like what I'm saying, a plus b are constant in the first equation, equals the first term, which is 7. That's the shortcut of it. So this is now your equation 1. For your equation 2, you will be using the second equation. So therefore, this one is 2a plus b equals 11. This is now your equation 2. To solve for a, you will be subtracting equation 2 minus equation 1. Alright? So 2a plus b equals 11 and minus a plus b equals 7. Subtract 2a minus a is a, b minus b is 0, 11 minus 7 is 4. Therefore, a is 4. Now to solve b, let us use equation 1. Equation 1 is a plus b equals 7 and the value of a is 4. Okay, so substitute 4 plus b equals 7. Okay, therefore b is equal to 7 and the opposite of 4 is negative 4. B equals 3. Now that's the time to write the equation using a sub n equals a n plus b, wherein the value of a is 4 and the value of b is 3. So a sub n now will be equal to 4n plus 3. So this is now your final answer, or the general term of the terms. Okay, so let's check using the first equation, or maybe we can use the second second term. Okay, 11. So we're in a sub 2 is 11 and of course n is 2. And then substitute to the general equation, a sub n is 11 equals 4 times the value of n, which is 2, plus 3. 4 times 2 is 8 plus 3. Therefore, 11 is equal to 11. You can also verify it using the other terms, or you can check using the other terms. Next. That's it. Okay, in these specific examples, we are able to learn on how to solve for the general term or the formula using the terms. Alright, so let's talk about series. We're done with the sequence. What is a series? This is very simple. The indicated sum of the terms of a sequence, that's the series. It can be denoted by S sub n. It means that we are talking about the sum of the n terms, where n refers to the number of terms. Types, also we have finite series and infinite series. Okay, example 8. Find the indicated value for each series. So 2 plus 4 plus 6 plus 8 plus and so on and so forth, S sub 8. So we are solving for S sub 8 here. So teacher, how are we going to solve for S sub 8? Of course, you have to add everything. 2 plus 4 plus 6 plus 8. But the only problem here, we only have 4 terms and then we have to add 8 terms. Okay? So get the pattern. The pattern here is adding 2 or skip counting by 2. So we need 4 more terms. 10, 12, 14, then we have 16. Okay? Then the last thing is you have to add them. If you have your calculators, you can just simply use your calculators in adding them easily. So in this case, the final answer here is 71. So S sub 8 is equal to 71 when you add them. Now let's have letter B. Negative 1/4 plus negative 1/2 plus negative 1 plus negative 2 plus, and so on and so forth, s sub 6. So we need to solve for s sub 6. But as you can see, we only have 1, 2, 3, 4 terms. We need to have the other two terms. So we have negative 1/4 here, plus negative 1/2, plus negative 1, plus negative 2, plus, and so on and so forth. I think this is geometric sequence wherein you have to divide to get the common ratio. So negative 2 divided by negative 1 is 2. Negative 1 divided by negative 1/2 is 2. And negative 1/2 divided by negative 1/4 is also 2. So to get the next terms, we have to multiply by negative, uh, we have to multiply by positive 2, which is the common ratio. So negative 2 times positive 2 is negative 4. Then lastly, negative 4 times the times positive 2 is negative 8. Then that's it. You have to add them all on your calculators. You will now be getting negative 63 over 4, or negative 15 over 3/4, or okay, we have negative 15.75. Either of the three is actually correct. But in your examination, please take note to read the instructions. Sometimes I'm going to ask you to write it in two decimal places, single decimal place, hundreds, tens, or maybe in fractions. So it depends on the instruction. That's it. When we say series, all we need to do is to add the terms. Okay? That must be the concept, the that you have to put in your mind. When we say series, you have to add the terms. It depends on what is being asked. Okay, next. How about summation notation? So the inconvenience of writing so many terms can be minimized using this symbol. It makes up the symbol uppercase sigma, just like what you are seeing on the screen or on the slide. A Greek letter equivalent to S, which is of course the first letter of the word sum. That's why this is being used to indicate that we are talking about some of the terms. So this was developed by Euler. No, this he was a Swiss mathematician. Now, if we're going to write the series 3 plus 5 plus 7 plus 9 plus 11, it can be written in the summation. This is how you will read it. The summation of 2i plus 1, wherein 2i plus 1 is the general term or the formula of the terms. So the summation of 2i plus 1 from 1 to 5. Why from 1 to 5? We are talking about the first term up to the fifth term. So it means we have 5 terms. So this is how you will read it. The summation of 2i plus 1 from 1 to 5. Teacher, can we use another literal coefficient other than I? Yes, of course. You can also use n, just like the one that we are using in the previous examples. So example, write each in expanded form, then find its value. Find its value. So first example, the summation of 2n from 1 to 6. How are we going to actually simplify and expand and simplify this? Take note that we are talking about 1 and 6. So therefore, there are 6 terms. So to expand this one, just change n to the value of the specific term. So 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5 plus 2 times 6. And then simplify. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. Then all you need to do is to add them all to get the sum, which is 42. The summation of 2n from 1 to 6 is 42. So that's how you're going to read it since the sum is already there. Next, we have letter B. The summation of n minus 1 squared from 3 to 5. So we are talking about from 3 to 5. So therefore, we are only talking about third, fourth, and the fifth term. So we will start from 3 in expanding. So this one now will become 3 minus 1 square plus 4 minus 1 square plus 5 minus 1 square. Then simplify. 3 minus 1 is 4 square plus 4 minus 1 is 3 square plus 5 minus 1 is 4 square. Then simplify again. 4 times 4 is 16. This is supposed to be 2. 3 minus 1 is 2. So 2 times 2 is 4. 3 times 3 is 9 plus 4 times 4 is 16. Then you have to add 4 plus 9 plus 16 is equal to 29. So therefore we can say that the summation of n minus 1 from n minus 1 squared from 3 to 5 is 29. That's it. That's now the introduction about sequences and series. So if you have a question, if you have questions and clarifications, you can actually comment, or you can actually message me, most especially to my students. For my students, you have to finish this one, and we will be checking it next meeting. All right, so I think that's the end, and we can call it a day. Saying thank you so much for staying in my class, and I do hope to be working with you with the next sessions that we're going to have. All right, so don't forget to hit the subscribe button and the notification bell for more videos. Again, I am Teacher Dong, and may you have a great day.